I'm Stephanie Zelenko, agronomist with AgroLiquid. In this Agronomic Advisor Focus, I'm going to cover nutrient interactions, looking closely at those micro and secondary nutrients and how they interact with one another, and ultimately looking at how to balance these nutrients to ensure the best utilization by your crop. Different nutrients have different charges, and these nutrients interact and react with one another. It's a balancing game, so we can ensure that the correct ratio of every nutrient is available for your crop to provide the ultimate best outcome. The moldage chart here demonstrates all of these interactions very well. You can see it's a very complicated web of lines going different directions. Some of them have a positive interaction where others have a negative interaction. But the key take home to this is all nutrients will interact with at least one other nutrient. Knowing your soil pH is a great guideline to help you determine that overall nutrient availability. On the soil report, a pH of 7 is considered neutral. So anything that falls either side of 7 is going to have an interaction with nutrients in the soil, and less of those are going to be available for crop uptake. When we're dealing with soils that have a low pH, anything 5.5 or below, many of our primary and secondary nutrients are going to be less available for crop uptake. On the flip side, if you're working in a soil with a pH above 8, many of those micronutrients are going to become less available. Some of the key interactions that I'm going to talk about today are the relationship between phosphorus and zinc, manganese and iron, phosphorus and calcium, and then a little bit about balancing your cations. When we're talking about all of these different interactions, the best thing and the best place to start is with a complete soil test. So not looking just at that pH in your primary nutrients, your N, P, and K, but ensuring that you have that percent base saturation, your cation exchange capacity, along with those micro and secondary nutrients, so we can get a complete look and a complete overview of what we're dealing with in your soil. The first interaction I'm going to talk about is the relationship between zinc and phosphorus. When I'm working on building a fertility recommendation for corn, or we're looking at a soil test for corn production, on the micronutrient side, zinc is the first thing that most people commonly address. And that's because we all know that zinc is very critical for high yielding corn. However, phosphorus is equally important, and we do a really good job of making sure we address those phosphorus needs because we know how critical it is to building a strong, healthy root system so that crop can take up moisture along with other nutrients. If phosphorus is too high, it can actually interfere with that zinc availability. An imbalance of these nutrients or an over-application of phosphorus, say with a manure application or an over-application of fertilizer, will decrease the amount of zinc uptake that can be done by the plant and can oftentimes actually induce zinc deficiency in your crop. Sometimes we'll even see this on a soil test. If you're looking at a soil test report that has excessively high phosphorus levels, and you look down to the zinc section, many times you can see that that zinc level is low or even deficient. I like this data here that was done by Kansas State University. This is looking at different applications, phosphorus only, zinc only, or the combination of the two, and then compared to no applications of fertility as well. If we're looking across this, they reported the parts per million in percentages in a tissue test, and they also provided the yield data. And if we look across there, where we applied phosphorus only, we actually had lower zinc amounts in the tissue along with a lower yield. So this demonstrates that an abundance of phosphorus is actually tying up and reducing that amount of zinc availability for that crop. Now, if you look where we applied both zinc and phosphorus, we got the best tissue levels, and we also had the highest yield. Phosphorus actually interacts with a lot of nutrients in the soil. Being a negative charge, it can fix or be tied up with any of the positive charges in the soil. So some of these include calcium, magnesium, iron, and manganese. All of these positive charges, just like a magnet, can be tied to that negatively charged phosphorus. When this tie-up occurs, the readily available phosphorus is unavailable to your crop. Nutrients are more prevalent in different soil pH conditions, and this can help determine what nutrients going to be tying up your phosphorus in the soil. Under low pH conditions, different nutrients will tie them up compared to higher pH conditions. Keeping your pH in line is probably the best way to ensure that you're going to have the most nutrient uptake for your crop. However, if you're working in those soils that have either a low or high pH, this can be challenging. If you have a low pH, lime applications can pretty easily fix this. High pH soils, a little bit more challenging. So a few other things that you can do: band apply your phosphorus. This ensures a concentration in the root zone to ensure the best uptake. Products like Pro Germinator and Spring Up are perfect for this application. You can add micronutrients to this to ensure that you have enough zinc and other micronutrients through applications of Micro 500 or Micro 600, and help ensure that all of these are in the correct balance to provide the best nutrient availability for that crop that growing season. The next interaction that I'm going to cover is two micronutrients, manganese and iron. And these two micronutrients are very critical for crops like wheat. When we're looking at that soil test, if we have manganese levels that are higher than iron, even if both of them are adequate or even high, iron actually will be limited and may show some deficiency symptoms. Here I have a couple of soil test examples that will highlight this, and you can see in both examples, both the manganese levels and the iron levels are very high. However, in the top sample, even with that really, really high level, because the manganese is higher than the iron, our iron's actually going to be limited, and we can see that deficiency. Where the bottom sample, those are more in balance, and our iron is higher than the manganese, so we don't have to worry about any induced deficiencies. If you're working in soils where manganese exceeds iron, and you can see some of that iron deficiency starting to occur, including AgroLiquid's MicroLink Iron or Micro 500 or Micro 600 to that fertility program will be beneficial. These products are very flexible. You can put them out through the planter in furrow or 2x2, or in a side dress or wide drop application, or even a foliar application. Next, I'm going to talk a little bit about balancing our cations. These cations that I'm going to focus on are potassium, calcium, and magnesium. Cations are positive charges that will attract to any negative charge in our soil. The majority of our soil, the clay and organic matters, are negative charges, and like a magnet will bind to these positive cations. Balancing these cations, which can be seen on your percent base saturation, is critical. Each nutrient has their own desired range. Looking at them individually, you want to have your potassium between 3 and 5%, your magnesium between 12 and 18%, your calcium between 60 and 65%. Kind of on the negative side, your sodium less than 2% because it can have some adverse effects. And then all of these are going to add up to 100, so the remaining percentages are going to fall under hydrogen. As I mentioned, these cations expressed on your percent base saturation need to add up to 100%. Because of the balance, if something is too high, then on the flip side, something is going to be low. Here are a couple of soil tests to use for an example showing, that balance of those cations. All of the numbers that are outlined in red are excessive numbers. So there's 3 soil tests here. If we focus specifically on that center one, the number highlighted in red is calcium, and that percent base saturation is 89.4%. So that's pretty significantly above that 60 to 75% ideal range. So because that number is high, something's going to be low. So if we look over at the potassium and magnesium, both of those numbers are low. Potassium's 1.6 and magnesium is 8.8. So a high calcium level is going to reduce the amount of potassium and magnesium that's available on that percent base saturation. These cations interact with one another, and it's critical to balance them on the percent base saturation. However, if they're in excess, they can have an effect on other nutrients as well. So using magnesium as an example, if we have a high amount or an excessive amount of magnesium there, then we're going to have less nitrogen availability for the crop. Therefore, in order to provide the plant available nitrogen that your crop needs, you're going to have to apply more pounds per acre to get the same result that you would with a well-balanced soil. It's all part of ensuring balance, just like I talked at the start. We need to make certain that all nutrients are in the correct ratios to provide the best utilization for your crop. For more information on this topic or AgroLiquid products, contact your local AgroLiquid dealer or visit our website at agroliquid.com. Thank you for watching this edition of Agronomic Advisor Focus.